Okay, the real question to Collat's conjecture. In my last video, I talked about Collat's conjecture, and I made a little oopser when it came to the 7, 22, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. Now just ignore that in the last video because I've corrected it in this one. Now again, the real question to Collat's conjecture. And the first one is, what is the rate of breakdown to Collat's conjecture? And the second question, what is the relative function of Collat's conjecture? And the relative function I've expressed in the last video as well. So now, if we look at n plus n is equal to time t plus 1. I'm referring to that if n plus n, if n plus n is applied, then that means that if we take any number and add it to any number again, it is equal to time t1. Now, n plus n is only applied if it's subtracted from n divided into 2. Because if the two numbers are even, then they create another even number. If they're odd numbers, then they ironically create an even number again. But that's why I'm saying that that function is going to be subtracted out. Now, n equals 1 is equal to p. It is something to remember as well. And p meaning point and is equal to n equaling 1. Okay, now n plus n is equal to time t1. Therefore, or 3n plus 1 subtract n divided into 2. And what I'm referring to is that if we take one number and add it to another number, it is equal to the time t1, meaning that the rate of time is equal to 1 if two numbers are added. And this condition is only applied if n and divided into 2 is subtracted out, meaning that it's only applied to odd numbers. Now, you might argue that it could also be applied to even numbers. Well, yes, you're correct, but it's the complete opposite of this formula. Now, if we were to observe the 7, 22, 11, 34, or 17, 52, 26, 13, 40, 20, 10, and 5, 16, 8, 4, 2, 1, and observe only the functions of odd numbers, and we measure the distances. So, 7 is 1, it's our starting point. It's 1, 2, 3. It's equal to 3 to the next odd number, and it's equal to 3 again to the next odd number, or 1, 2, 3. Now, if we were to apply this to 17 into 13, it is 1, 2, 3, 4. Now, if we were to apply 13 to 5, it is 1, 2, 3, 4, 5. And now if we were to apply 5 to 1, it is 1, 2, 3, 4, 5, 6. Or simply put, 3, 3, 4, 5, 6. Now let's observe the opposite. If we take 22, and we start there, and we move to 34, and 52, and 26, and the rest, then we have 1, 1, 2, 3, 4. And now, if I'm not mistaken, this looks like a perfect example of what a sequence is. And I believe that you could apply this to any of the function of Collat's conjecture.